Section 2.4 is using postulates and diagrams. The first slide here I have is a warm-up and a review from some of the other things we worked on in 2.3. So why don't you try these 3 questions, and then when you're done, check the answers. So here are the answers. So read through them. Writing by conditional, remember if and only if goes in the middle of your hypothesis and conclusion. When you're trying to decide whether a conditional statement is true or false, if it is false, you'd give a counterexample. And remember, the counterexample has to have the hypothesis true and the conclusion false. So in this case, you have to have a freshman. You have to have a freshman that is not taking driver's lessons. So my counterexample is Tanner is a freshman and he is not taking driver's ed. It's not enough to say Susie is a sophomore and she's taking driver's ed, because how do we know she didn't also take it last year? So you have to be very specific that the hypothesis has to be true and the conclusion false. And then the last one is using the law of detachment. So we are going to identify postulates from diagrams and use postulates to draw diagrams. So these are the postulates we're looking at. And with the postulates, we are not going to ask you to memorize postulate 5, blah, 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 blah. Postulate 6 is blah, 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 blah. But what you do need to know is you need to know these postulates exist, and you kind of need to know what they mean. So for example, postulate 5 says, through any 2 points there exists exactly one line. So here's what it kind of looks like. If you have 2 points, like A and B, right here, so you kind of think of these as more if-then. Then you have points A and B, and you have a line through them, like that. So if you have 2 points, that's your starting point, then there exists exactly one line. Postulate 6 is kind of the inverse, or it's the opposite of it. So this one says a line contains at least 2 points. So now you have, if you have a line, like line L, then what you have is you have line L with points C and D or A and B on it. So that's what these mean, and you want to be able to distinguish the difference between the two. Postulate 7, if 2 lines intersect, then their intersection is exactly 1 point. So again, if you have 2 lines that intersect, so line L and line M, then again what it is forming is that point. Then you have their intersection is a point, like W. Postulate 8. Through any 3 non-collinear points, there exists exactly 1 plane. So if you have points A, B, and C that are non-collinear, then you have points A, B, and C that are contained in 1 plane. We could call it plane P or something like that. Postulate 9, a plane contains at least 3 non-collinear points. So now if you have plane P, then you have plane P with points A, B, C. Postulate 10 says, if 2 points lie in a plane, then the line containing them also lies in the plane. So if you have this plane, and you have like plane P, and you have points A and B, then the line containing those 2 points, again, here's plane P, you have line points A and B, then the line containing them also lies in the plane. And last but not least, here we have if two planes intersect, then their intersection is a line. So here, if you have these planes intersecting, so if you have these planes intersecting, then their intersection is a line. And sometimes these are a little tricky to draw, but you'd have this intersection here between this plane and that plane being a line. So let's try using these examples and seeing if we can identify which postulates. Again, I'm not going to make you memorize that it's postulate 5 or postulate 8 or whatever, but you should be able to describe the postulate. So it says state the postulate illustrated by the diagram. So you can see that you have if these two lines are intersecting, then their intersection is exactly 1 point. So this happens to be postulate 7. If two lines intersect, then their intersection is exactly 1 point. Postulate 11 says you can see if you have these two planes intersecting, then their intersection is a line. That is postulate 11. Now again, you don't have to memorize the number, the postulate number. You could just say if two lines intersect, then their intersection, or they intersect in a point. Or something, you can even abbreviate and you can summarize, like if two planes intersect, they intersect at a line. Something like that. So you can abbreviate. I'm just going to use the numbers from now on because you have that list of postulates there. But keep in mind when you're doing your work, you can feel free to just abbreviate or describe it. So, example 2, it says use the diagram to write an example of the postulate from this diagram. So postulate 5 says through any 2 points there exists exactly 1 line. So we could use that diagram to say, so this is the example of postulate 5. We could say line N passes through points A and B. So this is postulate 5, and you can see that line N passes through those points. Okay, now we can look at postulate 6. Postulate 6 says a line contains at least 2 points. So now you could really just flip that around and say line N contains points A and B. And postulate 7 says, the postulate says if 2 lines intersect, then their intersection is exactly 1 point. So you could say that line M and N intersect at point A. So again, we could show line N and M intersecting at that point. Okay, let's keep moving on here. It says, use the diagram in example 2. Which postulate allows you to say that the intersection of plane P and plane Q is a line? Well, look through your list of postulates and you'll see that that is postulate 11. So again, we're going to use the diagram to write examples of postulates 9 and 10. All right, so postulate 9 says a plane contains at least 3 non-collinear points. So we can look at plane P. Here's plane P right here. So we could say that plane P contains at least 3 non-collinear points A, B, and C. So you can see here's A, B, and C is up here still in the plane. Postulate 10 says if 2 points lie in a plane, then the line containing them lies in the plane. So for postulate 10, we can say that point A and B lie in plane P. So the line containing A and B also lies in plane P. So again, if we highlight that, that would be this line right here. Okay, now this gets a little tricky at times, but do your best to sketch a diagram. So sketch a diagram showing TV, line TV, intersecting segment PQ at a point W, so that segment TW is congruent to WV. So that means they're the same. So first thing I'm going to do is I'm going to sketch the line TV, and now I need to have PQ, the segment. Notice the difference between lines and segments. We have segment PQ intersecting at point W. So here is segment PQ. Notice the endpoints compared to the line TV, and it's such that this piece, TW, is congruent to WV, and so now we drew that. And last example here where we're just touching on some different ideas interpreting a diagram. So which of the following statements cannot be assumed? A, B, and F are collinear. So look at points A, B, and F. Is there one line containing all 3 points? Yes. So that can be assumed. So we're looking for things that can't. This is true. Okay, so let's look at E, D, E, B, and D. Okay, so let's look at points E, B, and D. So we have E, we have B, and we have D. Now, it looks like they are like kind of forming a line, but there is no line containing them. So we cannot, there's no drawn line connecting them, so we cannot assume they are collinear. So this one right here, we can't assume. So this is false. We can't assume because there is no line drawn. Okay, how about the next one? AB perpendicular to plane S. So is segment AB right here? So is segment AB right here perpendicular? Well, AB perpendicular to plane S. There is no right angle marking, so I don't believe we can assume that. How about CD perpendicular to T? No. So we don't have any perpendicular markings. Oh, I need to erase this. I highlighted my perpendicular marking. So actually, if we get rid of this, that we can assume is true. This is true because of that perpendicular marking. But CD being perpendicular to plane T, there is no. So that one is false because no perpendicular mark. And the last one, AF intersects line BC at point B. So let's look at that one. So we have line AF, that's this line right here, intersecting line BC at point B, and you can see right here, point B. So yes, that is true. So those are the things you're going to be working on in section 2.4 is those postulates.